My name is Rong Chen. I'm a senior principal engineer in Cadence Tensilica IP communication group. Today, I'm going to talk about DSP in communication. So I will briefly go through 5G processing and then highlight some DSP features which are useful for the 5G processing. There's a lot of signal processing in 5G modem. The PHY or takes echo signal from digital frontend, and they decode different frequency channel, and output the control and data information to the L2, L3, L4. Of course, there is a PHY controller in the modem. B20 DSP has very good control code performance. You don't need separate controller. You can just implement the PHY controller on our DSP. We can zoom into each module in this diagram. Synchronization does timing, frequency synchronization, and find the cell ID. You can use FFT to do the coordination, which is more efficient than you do coordination directly. On B20 DSP, we have DSP instruction, which can generate different FFT size. Radix 2, radix 3, radix 5. After you have done coordination, you need to find the peak. We have dual peak search instruction on DSP to do that. Once you find the frequency offset, you need to do the correction. B20 has sine cosine complex exponent to generate the phase rotator for you. 5G is still off-dim system. So you need to do off-dim demodulation here. It does FFT again, FFT shift, DC remover. It tracks the subcarriers for reference signal, different physical layer channels. The channel estimator will take the subcarriers for reference signal to estimate the channels, do noise filtering, interpolation. So when you estimate channel, you need the reference signal locally. So B20 has the LFSR instruction to generate reference signal efficiently. The key is the FIR for noise filtering and interpolation. There are a lot of max on B20. It can do 128 max per cycle. So your noise filtering and interpolation algorithm can really benefit from the max on the machine. There are two purposes of channel estimation. So one is measurement, the other is demodulation. In 5G modem, there's a lot of measurements to do. RC measurement, RSRP, RSRQ, CSI, channel state information measurement. It selects the RI, PMI, and CQI and send it back to the transmitter side. The beamforming is a key enabled technology for 5G. In the measurement module, we need to do the beamforming measurements to select the best beam for transmitter and the receiver. Because the massive MIMO and the 4-dimension MIMO in 5G, you need to do matrix inversion for big size of matrix. So you need the high precision support. So B20 DSP has 32-bit support and also a single precision support. You can select different data type based on your algorithm choice. The main part of the PHY is to decode different physical layer channel for sure. So in order to decode different physical layer channel, you need to do the equalization and the decoding. equalizer takes the subcarriers from the off-gain demodulation module and what's the channels from the channel estimator module. It does MIMO equalizer, layer demapping, descrambling, and output the software information to the decoder module. So because of the massive MIMO, you also need the high precision support in the equalizer module. Again, we have the 32-bit native support and the single precision support on the DSP. And for the software information, it is 8-bit. So we also have 8-bit support on the DSP. You can use 8-bit instruction to do read matcher, interleaver. We also have the gather scatter feature on the DSP. You can do the interleaver kind of algorithm. We also have the FEC accelerator on the DSP. But we are only targeting the low throughput and medium throughput. If you have 1 gigabit per second kind of use case, probably you still want to do the decoder on hardware block. There's 3 major use cases in 5G and many, many different applications for each use case. So for enhanced mobile broadband, we have UE, G-Node B. For the ultra-reliable, low-latency communication, we have V2X, AR, VR. For the massive machine-type communication, we have industry IoT. Yeah, this 5G standard is keeping evolving, and it's complicated standard. If you use DSP in your 5G modem, you can program your algorithm in C. You can update your function by changing your software. And you also can implement the legacy standard like 4G, 3G on DSP by sharing the same hardware. In summary, you really can benefit the programmability from DSP in your modem. So we have optimized a lot of software, communication software on B20 DSP to enable your 5G modem design. Thanks for watching. See you next time.